Hello, guys. Welcome to this week's lesson. This week, guys, we're going to be learning about homeostasis and human body systems. And this is going to be really, really interesting, guys, because as you know, the last few weeks we've been talking about genetics. It was all about genetics and, how we inherit things. And we were also learning about some genetic mutations that can happen. So now we're going to get into some of the things that actually occur in our body, because now that we understand how DNA works, now that we understand how the information on the DNA codes for proteins, let's talk about what we use that information for. Let's talk about those proteins, the things that DNA is coding for. Let's talk about how it helps us stay alive, because really that's what homeostasis is all about. It's about staying alive, okay? So that's what we're learning about. And it's, like I said, super interesting. We're learning all about our bodies. So let's get started. Okay, so like I said, the goal is for us to learn about the impact on the human body, how different chemical substances, how environmental factors affect our bodies, how environmental factors relate to human activity, to investigate what they call feedback mechanisms in our body to help us to maintain homeostasis. And then we're also going to be looking at the anatomy and physiology of a lot of our human systems to help us to understand how our bodies use the organs that we have within our body to maintain homeostasis. So you're going to get to learn a little bit about the organs within your body and what they're there for. So, like I said, super interesting. All right, so first of all, now, normally we would do this in a class, or obviously we don't have a chat box here, but I just want you to think about this, okay? So you're outside, you're playing softball or baseball or basketball, whatever game you want to play. It's a nice warm day. What are two ways that your body adjusts? How does your body keep you cool and to keep your muscles working? So just think about that for a moment. Whenever you're doing any sort of activity, any sort of exercise on a warm or hot day, we know what happens to our body. Think about it. What does your body do? Sweat, right? One of the first things you do, you sweat. What else do you do? Your heart rate goes up. Don't you start breathing faster? Yeah. We learned early about cellular respiration. We learned that cellular respiration is needed in order for your cells to be able to function. So if I'm playing basketball, baseball, softball, whatever it is, I'm working out, to give my muscles the energy that it needs oxygen. Remember, we talked about that. We need oxygen. I got to breathe. And so if I'm working out, my muscles are demanding a lot of oxygen, right? So my body has to do two things. My body has to supply the oxygen, supply the energy my muscles need to be able to continue to work out. But it also has to keep itself cool, because we can't get overheated. We all know what happens when we get overheated, right? Pass out, you can die. Okay, so we can't allow ourselves to get overheated. So your body has to balance all of that in order for you to work out. Those are the type of things we're going to be talking about when we talk about homeostasis. Okay, there are, like we said, some of the things our body does: sweating to help us to cool. We're going to release heat by dilating our blood vessels. We'll get to that a little bit. But one of the ways that we keep our bodies cool is to sweat and to release heat. We got to release that heat from within. We're going to talk about how this happens in a little bit. So why is this important? Okay, why are we spending a whole week talking about this whole homeostasis? We're going to be talking about, it's one of the questions we're going to answer. What is this whole negative feedback system that we have in our bodies? It's something that's automatic, that just kind of happens. What's that? How does the change in external environment affect an organism? So when it's cold outside, how does that affect me? How does my body react when it's cold outside? How does my body react when it's hot outside? What does my body do to keep it alive? Because remember, this is all about survival. It's all about survival. How does an organism respond to change? And what happens if the organism fails to respond to change? It's a big one. What happens? So these are the questions we're going to answer through our lesson. We're going to talk about essential questions. Those are the 4 essential questions we're going to be doing throughout this lesson. So first and foremost, oh, by the way, as always, feel free to take notes. I am not going to grade the notes, but feel free to take notes if you want to. You're more than welcome to do so, because obviously all this information is going to be on your quiz. This PowerPoint is available for download in your agenda and canvas. So first of all, what is homeostasis? Okay, homeostasis in a nutshell is a way to keep your body the same. You see that prefix homo, homeo? Homeo, homo are kind of similar, okay? Homo means same. Homeo means same. So the key thing is we want to keep our body the same. That's what your body wants, because that's the happy place, if you want to call it the happy place. When we are the same, our body is stable and we're happy, okay? So our cells need to have the correct temperature, the right amount of glucose. Oh, wait a minute, what's glucose? Do we remember? Glucose. Sugar, did you remember? We gotta have we have to have the right amount of sugar, and we gotta have the right amount of water. So those are like the three like major things. Obviously, there are other things involved. Those are the three like major ones that we're gonna focus on this week, okay? Your body has mechanisms to keep your cells at what they call a constant environment, stable, sane. And it's going to keep it like that because that's where your body's happy. Like I said, that's the happy place, okay? That's the happy place. So in order to maintain homeostasis, we have 11 organ systems in our body. Oh my God! Yes, we do. When I talk about organ systems, what I'm talking about is a collection of organs that work together for an essential goal. So for instance, I'll give you an example. Breathing, okay? In order to breathe, we need multiple organs. In other words, your lungs by itself is not going to help you to breathe. The heart by itself is not going to help you to breathe. They got to work together. So you need the lungs, you need the heart, but you also need vessels. You need blood to transport the oxygen that you breathe in. How are you going to transport it? I need red blood cells. So I need a circulatory system. So when we talk about something like breathing, it's not just one oxygen. We can't just say, oh, I need my lungs to breathe. No, lungs is part of the organ system. So when you're learning anatomy and physiology, which by the way, if you ever get a chance to take that, especially at the college level or if they offer it in high school, take it. It is phenomenal. But in any case, when you learn about the organ systems, you learn them as a system. So like you learn the respiratory system, and the respiratory system would include things like my lungs, my heart, our circulatory system, which is all the blood vessels, the red blood cells, things like that, because they all work together to help you to breathe and to bring that oxygen and to release the carbon dioxide. Our diaphragm is part of that too. So the point I'm making is it's saying organ systems because it's a collection of organs that work together to maintain homeostasis. It's not just one thing. It's everything together that has to work together. Homeostasis, again, is a process in which the organism keeps internal conditions relatively constant, that happy place, that balance. That's what we want. When your body is at homeostasis, you feel good. So right now, if you're feeling relatively good, you're at homeostasis. When I say that, I mean like if you're, you don't have any really aches or pains, you're not, coughing, you're not, feeling weird. If you're feeling pretty good, then you're pretty much at homeostasis. So help us to understand homeostasis. One thing we can relate it to is a thermostat. Now, we all have a thermostat in our house. Now, in my house, nobody can touch thermostat because we like our house to be at a specific temperature and it stays there. We keep our house at 74 degrees, period. So when it's hot outside, what does the thermostat do? Here in Florida, we can hit 100 easy. My thermostat will tell my AC unit, hey, it's too hot. Cool it down to 74. So my AC would kick on and the inside of my house will drop down to 74. On the flip side, in the winter, when we have our few cold days, let's say it's 50, which isn't all that cold for you guys, but it's cold for us in Florida. When it's 50, my thermostat says, hey, it's too cold. You got to warm it up. So now my AC unit will click into the heating mode and will heat my house up to 74. The concept is the thermostat is always going to maintain the same temperature in my house, 74. Whether it's hot, it'll cool it down to 74. Whether it is cold, it'll warm it up to 74. Think about your house. I don't know what the temperature is in your house, but whatever it is, isn't it the same concept? You keep it at a comfortable level. Whatever's comfortable for the people in your house, that's the temperature you keep it at. And that's a thermostat's job. It makes sure that the air is always the same. So the second the air gets too hot, the AC kicks on and brings it down. The second the house gets too cold, the heater kicks on and warms it up. So your thermostat constantly does this. It is constantly cooling and warming your house to maintain a homeostasis in your house. Guess what? Our bodies are the same way. So for us, what's our magic temperature? Like I said, in my house, it's 74 degrees, but you know what? Not your body. Your body is 98.6 or 37 degrees Celsius. This is the magic number, okay? This is what your body wants. Now, when I say 98.6, I'm talking about your internal temperature, not your extremities, not your toes. Why? Because since your hands and your feet are further away from the core of your body, oftentimes your hands are a little bit colder than the core of your body. So like if you would take a temperature of like the skin of your hands, it might be a lot lower than 98.6, but that's okay because your body wants to maintain its major organs at that 98.6. Hence, when they take your temperature, they don't take the temperature of your hands or your feet, right? No, they take it up your forehead. They'll put it under your tongue. They might do it under the armpit. Like there's different places that they do it. But they're looking for that internal, the core part of your body. Talking about the trunk of your body. That's the temperature they want to maintain. It has to stay at the 98.6. That's the magic number, okay? If it is too hot, your body will cool itself. If it is too cold, it'll warm itself. It doesn't matter what temperature it is outside in the world, your internal organs need to stay at 98.6. So hence, it is cold in Cali. It's cold wherever. You go outside, your hands are freezing, your feet are freezing, you are bundled up. But you know what? You don't die because your internal organs are 98.6. You know what I'm saying? So even if your hands are cold and your feet are cold, you can still like function because your internal organs, your major organs are all at that 98.6. And your body will fight to make sure that your core stays at 98.6. All right, so our body is under constant, what they call environmental stresses. Environmental stresses are just things that threaten the delicate balance in our body, okay? So our body is constantly trying to keep it here. But the outside world will nudge it up, nudge it down, it'll nudge it this way. Like the outside world is constantly attacking us with different things. And our body is constantly fighting to keep it at the happy place, that homeostasis. So hence, our body requires multiple systems in order to get this to work properly. All of these things work together. They all interact to maintain that homeostasis because they all got to work together. Because if they don't, there's an imbalance, and an imbalance means you're sick. And we don't want to be sick. We want to be well. And so to maintain that homeostasis, everything has to work together. All right, so our bodies must carry out a series of chemical reactions in order to grow, obtain, and to reproduce. Okay, we got to move, we got to breathe, we got to maintain heat, we got other things to do. We can only do these things if the environment inside of our body is stable. Think about it. If there is an imbalance in your body, a child can't grow properly. If a child isn't taking in enough nutrients, let's say a child is malnutritioned, there isn't enough food. If you're not bringing in that nutrients, your digestive system can't work properly. And if it can't work properly, it can't give the nutrients to your cells. And if your cells don't get it, now the kid can't grow properly. Or you have low energy because you're not eating right. You know, you got to have the things have to be balanced in order for everything to work well. That's why homeostasis is so important to us. That's why it's a matter of life and death, really. Our bodies can detect and respond to internal and external variations. It can detect the response at both the cellular and the organism level. Think about that. Our bodies can detect changes. Not only big changes, like you go outside and, oh, it's cold. Okay, that's a big change. That's my whole body detected that. But your body can detect cellular changes. Have you ever like woke up in the morning and you just kind of feel something in your throat? or have you ever just not felt well? Like you couldn't even put your finger on it. You know, you're like, I don't know, I just don't feel well. I don't know, so it's not right. That's your body responding to something at a cellular level. Your body's telling you there's an imbalance somewhere. Even if you don't know where it is, because I know that's happened to me where I'm just like, I just don't feel good. I don't know where, I just don't feel, something's not right. Your body's telling you something's not right. Your body's telling you that at a cellular level, something's not right. Something's not balanced. It could be an intruder, like a virus or a bacteria. I mean, it could be a series of things. But there is an imbalance, and your body will tell you. And you'll know because you don't feel good. Sometimes you can pinpoint it. Ouch. Have you ever like just did something, all of a sudden you're like, oh, my finger hurts, and you look and you see you have something stuck in your finger? Where did I get that? Isn't it wild how things can happen to you and you don't realize you have a little pain? Or you look at, oh my God, I have a little cut here. Oh, when did that happen? So even if you don't even aware of it, your body's aware, and your bodies can tell you that, hey, something's not right here or there. And it will detect, and it will tell you something's not right. And one way that it tells you that it's not right is called pain. That's what pain is. Pain is something's not right. You know, when you feel weird and something's not right, that's your body saying imbalance. That's your body responding and telling you, hey, pay attention to this. You know, it's funny how you never feel your insides. Like you don't feel your digestive tract. You don't feel like all the stuff going on in your body. You don't feel it and something goes wrong. You know, something goes wrong. You feel it. Something's wrong in your stomach. Maybe you ate something you shouldn't have ate. Now your stomach's all, you know what I'm saying? Now all of a sudden you feel that. You know what I'm saying? When there's that imbalance, you feel that. So whenever you start feeling that pain, that discomfort, that's your body saying something's not balanced. We need to address it. And it's telling you, be aware, something's not right. I need you to address this so you can fix it. Why? Because failure to respond can result in an organism's death. Now, I am not saying that, you know, if you got a splinter in your finger, it can result to you dying. Okay, I'm not going to go that far. But the point that I'm making is this: when you got an imbalance in your body and you don't really address it, it can lead to death because your body has to be balanced. So it's just like the people that maybe have pain, they ignore for years. And when they go to the doctor, they find out, oh, they got this big tumor inside of them that's been growing like crazy. Their body was telling them, but they didn't address it. So that's that kind of thing. Like we got to have that balance. And your body's going to tell you when it's not right. And if you don't address it, eventually it can lead to death. It can, because we got to have balance. That's just how our bodies work. That's just it. So let's get into some specific systems. Let's talk about the thermoregulation system. Let's break down the word thermo. What do you think of? Think about thermostat in the house. What does a thermostat do in the house? Maintains the heat. If you have a thermometer, what does a thermometer do? It measures the heat in your body. If you have a thermal mug, What does a thermal mug do? Doesn't a thermal mug keep the heat in of the liquid that's inside of the thermal mug? So the thermal means heat. So thermal regulation system is our heat regulation system. Let's talk about that first. All right, so how does my body cool down? We already said it, sweating. So this is our body's response. Have you ever wondered why you sweat? Well, now you're gonna find out. When your body's hot, you have something called sweat glands within your cells, within your skin. You have these sweat glands, and it releases sweat, okay? It's just that liquid sweat is going to evaporate off of your skin, and when it evaporates, it's gonna take the liquid with you. Let me show you this in an illustration. All right, so imagine this is your skin, okay? Your skin has multiple layers. Within your skin, you have these sweat glands. And yes, your sweat gland looks like this. Looks like a coiled mesh ball or some sort. It looks like that. So it's going to release this water. Okay. In that sweat, there's a series of different things. I think I have it at the bottom of the screen here. Is it there? Nobody erased. Okay. But in your sweat, you have a series. They don't only have water, obviously, but you have some salts. If you've ever tasted your sweat, sometimes it tastes a little salty. But it also releases waste. So you have some urea in it too. Not urine, okay? Urea is a chemical that's found in urine, but urea is a waste product that often comes out in your sweat. So your sweat can be salty. Like I said, it has the urea in it. And what happens is as the water goes onto your skin here, it's going to evaporate because it's hot outside, right? The way it evaporates is the heat in your skin heats up the water and makes the water turn into a gas. So when the water evaporates, it's actually pulling heat out of your skin. That's why we sweat. That's why it's an efficient system. But it only works if you actually like evaporate the sweat. If you've ever been someplace like, what do they call the spa rooms, the sweating rooms. Oh my gosh, I can't think of the name of it now. You know, where you go and you sweat. Oh my gosh, what is the name? This is ridiculous. I can't think of the name of it. But you know, you have the sweat room. You just sweat, the steam room, that's it, the steam room. Okay. The concept of the steam room is they make you hot to sweat and sweat and sweat, to keep sweating. But the problem is you don't really evaporate the sweat. So they just want you to get hot to release lots of toxins and things like that. But in everyday life, when we're outside, you sweat. If the breeze comes, you probably notice you feel cooler because, again, as the water evaporates, it's going to suck the heat out of your skin. So it takes heat with it as it evaporates. Okay, so that's how it helps to cool down your body. So sweating is a good thing. Actually, there are some genetic mutations, it's rather rare, where people lack sweat glands and they can't sweat. And that's actually a really bad thing. When people cannot sweat, that can kill you because you can't cool down. And if you can't cool down, it's like having a fever. And we all know you can't have a high fever because you will fry yourself. You literally will cook yourself from the inside. So sweating is a good thing. It may not be very fashionable. You know, who wants to have little sweat spots under their arms, right? But sweating is a good thing. So be happy that you sweat, okay? You want to be a sweater because sweating is good. All right. What's the next thing our body does to cool down? Something called vasodilation. Let's break it down. Okay, so vaso, that's like vessels. So think about blood vessels. Dilation, dilate. If you've ever been to the eye doctor, he dilates your eyes. That means he takes the iris and he opens it up and he makes it really big. Women, when they're about to give birth, they dilate, okay? So their insides start to open up so that the baby can come out. So dilate means to get bigger, to open, okay? So vasodilation means your vessels are going to open up. Why? Because it's going to carry that heat energy from the internal part of your body out to the outside of your body, to the skin portion. You have capillaries beneath your skin that fill up with blood if you're way too hot. So let me show you what that looks like. Okay, so at the surface of your skin, you have capillaries. These capillaries are tiny, tiny vessels. They're literally like one red blood vessel wide, which is very, very tiny. And that's normal. However, when you're hot and I want to release energy across my epidermis is your skin, okay? Like a dermatologist takes care of your skin, okay? Epidermis is your upper skin, it's your skin. It's the skin that you look at, that you touch. So what I want to do is I want to sweat, but I want to pull the heat. So my vessels here are going to open up, which is going to draw blood, a lot more blood from my core outward towards the skin area, carrying all that heat. And as the sweat evaporates because of the heat is going to be pulled out with that sweat that's evaporating. So that when the blood goes back into my body, it's slightly cooler than when it entered. Does that make sense? So I'm losing that heat. I've opened this up and I'm losing that heat. Hence, if you're a fair-skinned person and you're very hot, you tend to get a flushed look. That flushed look is this, vasodilation. Okay, that's that flushed look that someone gets when they're really, really hot, especially if they're fair-skinned, you can see it. That's because all of their capillaries underneath their skin is opened up, giving them that kind of flush, reddish look to their face. Now, our body can do the other thing, though. What if I'm cold? Okay, so with when I'm hot, my body is trying to save my organs. Okay, so my body does not want my organs to go, the temperature to go too high. Remember, 98.6 is the magic number. So if I'm too hot, I can't let my organs get high. The temperature can't reach 100, 101, 102. I'm going to bring it down by sweating, vasodilation. But what if I'm cold? I don't want my organs to go below 98.6. So I got to find a way to warm them up. And this is how I do it. Vasoconstriction. Vaso, vessel, blood vessels. Constriction. Think about a boa constrictor. What does a boa constrictor do? How does it kill its prey? Doesn't it squeeze the prey? Like it wraps and squeezes them? That's a boa constrictor. Okay, that's what constricting does. A constrict means to close in, to make small. All right. So this is the opposite of vasodilation. That means your capillaries with your skin are going to actually cut off. They're going to shrink. So restricting the amount of blood that goes to the surface of the skin, and it looks more like this over here. You see how much thinner it is? Okay. Hence, when you're cold, if you're fair-skinned, you might tend to look slightly pale. You get kind of a pale look to yourself. That's because all of your capillaries have kind of slowed down, they've constricted, so they're minimizing the amount of blood that goes here, flushing more blood towards the inside of the body, keeping all the warm blood towards my organs. So that's how your body can stay warm. Now we know there's other things that can happen too. We'll get to that in a second, but let me give you that illustration here between the two. So if this here in the middle is my normal blood vessel, okay, let's say this is normal. You see how many's here? What would that be? 1, 2, I should do this one here. Okay, yeah, so if this is normal, okay, I have 1, 2, 3, 4, 1, 2, 3, 4. Okay, so if I'm going to dilate, you see this one here? Let's say this is normal, sorry. This is the normal one. So I have what, 1, 2, 3, 4 here, okay. So this is normal. You see how the edge here is thinner than that? You see that? So if this is normal, I was wrong the first time. This is normal, this is dilation. You see how this is thicker than this? This is thinner than that, allowing more in, okay? Now compare this to that one. You see how this one is thicker? This would be more like constriction because it's thicker than that one. So if this is norm, this is vasodilation, vasoconstriction. You see how the blood vessels are closer together? Okay. Normal, vasodilation, opening up, vasoconstriction, closing in. Vasodilation when I'm hot to release heat. Vasoconstriction when I'm cold to pull heat towards my core. All right. What else does my body do to warm up? Pilar erection. What is that? Okay. So erection, I know what you guys are thinking. But the word erect in and of itself just means to stand up. So you can stand erect. So like right now, someone tells you to stand up, stand erect. That means you stand up, okay, like that. Excuse me. So pilar erection has to do with your hair standing up. Excuse me. We commonly call that goosebumps. Some people call it chicken skin. I've never called it chicken skin. I've always called it goosebumps. So goosebumps. That's when your hands stand up on end, okay? That's one way of doing it to help, again, trap the warmth in your body. So here's a picture of it. So believe it or not, really cool. Like I said, taking anatomy physiology is awesome. But your skin, every one of your hairs has a tiny muscle attached to it. It's called an erecti pili muscle, okay? Erecti pili muscle. And its job is to occasionally tighten up. It'll contract. And when it does that, it pulls your hair from laying down to standing up. And when it does that, it actually like tightens your skin a little bit. You get that kind of goosebumps look here. And it helps to constrict your skin, which in turn helps to hold the heat in. So it's another way of keeping you a little bit warm, okay? So can you believe that every last one of your hairs has a tiny little muscle? Isn't that cool? It's awesome. You don't think about that, but yeah, you have a little hair, a little muscle, every little hair. So when you get those goosebumps, that's what's happening. Your erecti pili muscles contracting, pulling your hair up. And that's another way to keep ourselves warm. And of course, we also know that we can shiver. Okay, that's another thing that we do to warm up, right? So by doing this, by contracting our muscles intensely like this, it generates heat. So we're generating heat. We are vasoconstricting, pushing more blood towards our core. We are doing what they call pili erection, or we're having goosebumps to help constrict the amount of blood going to our skin, hence keeping all the warmth at the core. So when it's cold outside, your hands are freezing, your feet are freezing, but your core, the organs that matter, stay at 98.6. And again, why? Because you know what? The way your body looks at it, your hands and feet, yeah, they're important, but they're not as important as your heart. They're not as important as your liver or your intestines. Like everything here is number one priority. Your body will give up a hand or a foot to keep your organs in the inside alive, okay? So that's how your body maintains homeostasis as far as your temperature goes, your thermal regulation system. So that's what we just went over. Let's talk about glucose levels. Sugar. All right, so we have to maintain proper amounts of sugar in our blood. We need sugar, okay? I don't care what diet you're on, you need sugar, okay? We know that. We need sugar for cell respiration. Remember we went over that? We talked about how glucose breaks up, how we snap it apart to release ATP, okay? So we gotta have sugar, but it has to be at the right amount, okay? So your body can regulate how much sugar is in the blood system. It can bring it down if it's too low, or it can bring it up if it's too high. And that is regulated by two organs and by two hormones. So we need our liver and we need our pancreas to get this to work. We need something called insulin and glucagon, which you can't see on the screen. You'll see on the next one, I think. Okay? So where are my organs? Well, first of all, guys, let's do a little bit of anatomy. So if you are, take a look at yourself, okay? You want to go to the right side of your body. If you take your hand on your right side and feel your ribs, okay? So, you know, you have your waist, and you feel your ribs up, and you have your center, okay? So your heart is here in the middle. Below that, starting at about right here and to the side, underneath your rib cage is where you'll find your liver. It's kind of like, well, it's partially under, partially, I should say it that way, because part of it does come underneath. It's like right here. So kind of part of it's protected somewhat by your rib cage, and part of it isn't. So it's kind of like from the center here coming out kind of towards your waist. That's where your liver is, and it's huge, 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 okay? It is huge. It does have multiple lobes. I believe it's like 2 or 3 lobes it has, but anyway, it comes around here. Your pancreas is kind of underneath and behind your stomach. Okay, so where's your stomach? Now, I know you guys are like, here's my stomach. No, believe it or not, your stomach isn't your stomach. Your stomach is actually in your intestines, okay? Your stomach is way up higher. If you go to the left side of your body, take your hand. Again, find your rib cage, okay? Again, here's my heart. If I come over here to the side, around the area of my rib cage is where you're gonna find your stomach, okay? Your stomach is not this whole thing in the center. No, your stomach is actually up here in the corner. It's around here, all right? And your pancreas is kind of in the middle, but under and behind your stomach. So like here's the stomach. You see how the pancreas is being shown here? And it kind of shows it like behind. So it's kind of under and behind your stomach, okay? But it's kind of like center and kind of like there. But this is your actual stomach. All this stuff, you know, the gut that we always talk about, that's really all intestines. It's not, we call it the stomach, but technically speaking, it's not your stomach. It's your intestines, yeah. That's why when you have gas, the gas that you're feeling is all in your intestines. That's where all that gas and that bubbling that you get sometimes when you're a little gassy, that's all intestines. It's not really your stomach. We just say that, but it really isn't. In any case, so liver and your pancreas is what we need for this. So what happens? I am eating up some good old sugar. So some Snicker bars, you know, whatever, Skittles. If you're an M&M gal, I love me some M&Ms, peanut M&Ms, almond M&Ms, hey. All right, so whatever sugar I'm eating, it comes into my body, it breaks down. All that sugar goes into my bloodstream. My body has a regulatory system. My body knows how much glucose I should have floating around in my sugar and floating around in my bloodstream. If I have too much, my pancreas will kick in and will release something called insulin. You guys heard of that, right? Especially if you know somebody that's diabetic, you know about insulin. So insulin will convert some of the glycogen it's going to convert some of the glucose to glycogen in my liver. So it's going to pull sugar out of my blood. So let me say that again. So I'm eating my candy, my blood sugar count goes up, but it's too much. You can't have too much sugar in your blood because that'll literally kill you. That's why a person that's a diabetic has to take insulin shots, because they will go into a diabetic coma and they will literally die because you cannot have too much sugar in your bloodstream. So your pancreas will detect the levels too high. It'll release a hormone, a protein called insulin. It's an enzyme, I should say enzyme. It's going to release the insulin. The insulin is going to grab the glucose that's in your bloodstream, convert it to something called glycogen, and store it in your liver. So your liver is going to store this glycogen. It's just going to kind of sit there, okay? Now, over time, later on in the day, I'm not eating any more sugar, I'm drinking some water, maybe I take a nap, whatever the case is. Now the blood sugar, the sugar in my blood has decreased. It's going down. All right, so now that it's going down, I have to have that homeostasis. So when it gets too low, there is an enzyme called glucagon that's going to take the glycogen, take it out of the liver, convert it back to sugar or glucose in my bloodstream so that the level stays balanced. So my glycogen is going to turn back to glucose. So the glucagon is going to be used to convert some of the glycogen that's stored in my liver and turn it back into sugar or the glucose in my bloodstream. So this way I keep that balance. Gotta keep that balance. That balance is very, very important. Problem with diabetes. Some people don't produce enough insulin, and that becomes a problem. Because if you can't regulate your blood sugar, like I said, it's gonna kill you. It's gonna kill you. So what do they have to do? Some of them regulate it by the way they eat. If the diabetes isn't so bad, sometimes they just kind of watch what they eat. You know, they gotta have, you know, the right amounts of sugar. They'll eat some, but not too much. Sometimes that's okay. Sometimes their insulin is so bad, like, I mean, because sometimes their pancreas releases a little bit of insulin, but not enough. So they can control it with eating properly. Sometimes their pancreas is like completely shot and like there's no insulin coming out whatsoever. They have to get shots. So they give themselves their shots. They check their glucose. If you know someone that's diabetic, you know, they always have to prick their finger and they test how much sugar's in their blood. And if the sugar's too high, they get their shot of their insulin. If the sugar's too low, then they'll go eat a hard piece of candy, you know, something like that. They have to keep that balance, you know. A person that's diabetic, again, if you know someone, you know, they'll tell you, oh, I'm not feeling good. It's because their sugar dropped too low. Because their pancreas isn't working properly, they can't regulate the blood level properly. So if their blood sugar gets too low, they get dizzy and I don't feel good. And you gotta give them a little bit of orange juice, or you give them a piece of candy. Or vice versa, they eat too much and now they're going into a diabetic shock and I gotta give them a shock of insulin. Their bodies can't keep that homeostasis. So that's why diabetes is a condition that is life-threatening. It can kill you if they don't regulate it. Now, diabetes is something that can be genetic. It can be genetic. So if it's in your family, you can have a gene for this. And you can actually test for it to see if you have a gene that kind of inclines you towards it. But having a gene for diabetes doesn't mean you're actually going to get it. It just means that you are susceptible to it. So usually if a person has that gene, that marker that they look for in genetics, they will tell you to watch what you're eating now so you don't trigger it to happen. And so as a young person, this is the time when you want to make sure that you're eating properly so that you never trigger it in the future. Now, I can't, let me not say the word never because, you know, things happen. But you can lower your chances, put it that way. By eating properly now and not overdoing your sugar intake, you can decrease the chances of you ever developing diabetes in the future. Because even if it's not genetic, it's something you can develop over time, even if it's not necessarily in your family. If it's in your family, then you're more inclined towards it. So you really have to watch it. Like in my family, we have diabetes. So I have to watch my sugar intake, and I have a terrible sweet tooth. So I have to make sure I get lots of water. I gotta, you know, I just have to be careful. I can't like completely binge on a whole bag of Skittles because while I don't have diabetes now, I don't want to trigger it because I know it's in me. I have that tendency in my heritage. So I have to just watch it. Okay. But in any case, so that's what diabetes is. Again, it's not homeostasis. And so therefore it can cause a big problem. All right, what about water levels? This is the third thing we're going to talk about. This is really important. Okay, so water is controlled by our kidneys. We all know about this. Urea, urine. Okay, so what is urea? Urea, guys, believe it or not, is a waste product that's made in your liver. When your liver breaks down proteins that are not needed in the body, the waste product is urea. Urea contains nitrogen. And what happens is your liver will release that into your bloodstream and it will make its way to the kidneys and then be removed. Your kidneys clean the waste products out of your blood. So not just the urea, but other waste products. There's all kinds of waste products in the bloodstream that can be there. And your kidney will remove it all. The combination of all of that, the urea plus whatever other waste products your body is excreting, that's what urine is. So remember earlier when I said how urea comes out of your sweat? The urea that's coming out of your sweat is the byproduct from your liver. Because your liver like filters out your blood. Your liver will remove all kinds of toxins from your blood. Alcohol, medication, like all kind of stuff. Like it just, any kind of like toxin that comes into your body that's considered like a toxin, your body will remove. And it will break it down, and it breaks down in your liver, okay? So one of the things that also breaks down is proteins, which becomes urea. Some of that urea comes out of your sweat, but urea is not urine. Hence, when you sweat, it doesn't smell like urine because it's only the urea. Your urine is urea plus other stuff. Hence, your urine has a distinct smell to it. Okay, so just so you get that differentiation in your mind. Okay, depending on how much blood is in your blood, how much waste products and how much water is in your bloodstream will determine how much urine you have. It's excreted something called the ureter, which I'm going to show you guys in a second. Dirty blood will enter into your kidney, something called the renal artery, and I'm going to show you what that is in a second. And then it goes through a series of steps to actually clean out the blood. So first of all, where's your kidneys? All right, guys. Now, for those of you that are into boxing, you all know about the kidney punch, right? So in boxing, the kidney punch is when they punch them in the lower back. So if you take your hands, feel your back, I want you to find your rib cage, okay? So if you, depending on what your backs are like, you find your rib cage about to the left and right of your spinal cord. So here's your spinal cord. You want to go to about your waist, okay? Around right here, it is kind of behind your ribs because you have ribs there. You have what they call the floating ribs there. So you have the ribs there. And it's on both sides here. About right here, give or take, is where your kidneys are. So in boxing, when they do that punch towards the back here, that's called a kidney punch because you're actually hitting them and where the kidneys are located. Your kidneys are kind of, if you ever get a chance to do a dissection, you'll see what I'm talking about. But your kidneys are like embedded in this mat of fat. Yeah. So anyway, so all of your back has like all this fat on it. And in that fat is embedded your kidney. And a kidney literally looks like a kidney bean. So if you've ever seen a kidney bean, or if you eat them like I do, they're good. They're called kidney beans because they literally look like your kidney. I mean, literally. So here are your kidneys. One on the right, one on the left. Down the center, which is kind of like in front of where your spinal cord is, you have these major veins and arteries. This is a major artery coming from your heart. And this is a major vein going to your heart, okay? So the blood will get filtered as it's coming through these vessels. It'll go into the kidneys, get cleaned out, and then come back out as clean blood, okay? Below your kidneys, well, attached to your kidneys are these little thin tubes. They're called ureters. Then you have your bladder, okay? Your bladder is down by your pelvis. So if you were to take your hands and find your pelvic bone, okay, you got your hips. Your pelvic bone kind of comes down kind of like this. So about this area where your pelvic bone meets is kind of where your bladder is, give or take, in that area, okay? Attached to your bladder is called the urethra. Both boys and girls have a urethra. Obviously, the length of the urethra in a girl is a lot shorter than the length of the urethra of a boy. Because obviously, for a boy, the urethra extends the length of their penis, right? Because that's where the urine comes out. So for a guy, this part here will be a lot longer than a girl. Okay, so that's your basic anatomy of your, what they call the urinary system, okay? So here is a cadaver shot of an actual kidney. I know, kind of gross looking, right? Okay, well, first of all, obviously it's dead. It doesn't have the appropriate color to it, but we've cut it straight down the center. So I want you guys to get an idea what it actually looks like. So the outside of your kidney here is where the actual filtration takes place of the blood. We're gonna get into that in just a second. But in here, you have something called nephrons, and this is where the blood actually will come in and get literally filtered. This big open cavity area here is where the urine that's pulled out of the blood, it goes into this cavity. It's called the renal pelvis. It goes into this like open cavity. It kind of gathers here, and then it goes out the ureter. This piece right here, it comes like the opening to a tube. That's what it is, opening to a tube. This is the beginning of the ureter. Okay, so the urine that's pulled out of the blood here will kind of trickle its way into what they call the renal pelvis, which what this is here. It will trickle its way here, make its way, and then it'll make its way into the ureter, which is a little tube here, and then go out of the kidney into the bladder and out through the ureter. This here is a close-up of what's here. Now, I know when you look at it, it looks like sponge. Seriously, if you ever get a chance to do a dissection, And when you cut open a kidney, it literally looks like a sponge. It's hard to tell what's even there. But what's here is what you're seeing here, okay? So you have this collection of tubes, really cool stuff. You have an area where the blood will come in, and it goes to what they call a globular bulb here. So thing right there. I think this picture's a better picture. Yeah, it is. Okay. So it's Bowman's capsule, or the glomulus. Say that 10 times. Glomulus. Okay. So in any case, so the blood comes in. The blood comes in to this little capillary here. What's really cool, and this is, oh my gosh, this is so amazing. Okay, so you know, in your blood, you have like tons of stuff, right? You got water, you got red blood cells, white blood cells, you got sugar, you got ions, you got salts, you got waste products. I mean, you got a slew of stuff in your blood. Well, it separates here in this little capsule here, the Bowman's capsule. It separates, like it literally like splits apart. So it takes everything out of the blood. And so now you have a tube here that just has like plasma in it pretty much, you know, some like random fluid. And in this tube here, you have everything that was in the blood, okay? I mean, the red blood cells are here too. I should say that too. The red blood cells don't come out. But in here, you'll have like water, you have salts, you have the urea, you have all the extra stuff will be here, okay? In this tube. And as it goes through, what the body wants to keep goes back into the blood vessel. What the body wants to release as waste product stays in the white tube and then goes out here into that collection area that I showed you in the kidney. So let me say that again. So the blood comes in here, okay? It separates, like all like the liquidy stuff kind of comes out. Mine is like the red blood cells, but like it separates, okay? So it separates into two, now you have like two major sections. So now in here has just basic stuff. In here is everything else. As it goes through, anything your body wants to keep will go back into the red blood cell. Excuse me, say it again. It will go back into the blood vessel. What it doesn't want to keep, whatever's a waste, stays in the white tube. So by the time it gets to the end here, it is all waste product leaving the body. Let me show you that. Let me show you that in another image. I think it's in this one here, yeah. Okay, so if you can imagine, this is the tube, okay? I'm gonna show you the two tubes, okay? So here is the blood vessel. The blood vessel is going to keep the red blood cells, the white blood cells, like the good stuff. The major good stuff is going to stay in the blood vessel. But that clear, that like tan color tube, this tan color tube here is what I'm showing you here, okay? So this is the stuff that came out of the blood. So the sugars, ions are like salts. We have potassium, calcium. I mean, there's a slew of ions that we have in our bloodstream because we have to have them. In any case, all of that stuff plus water and urea is going to go into that tube. Now, as the tube is going through the little series, it's going to pull back sugar. It's going to pull back the sugar, and it's going to reabsorb some of the sugar. Okay, if we have too much, it might excrete some of it, but it's going to absorb a lot of the sugar back. It's going to absorb some of the water, some of the ions that it needs. Okay, so some of that will come back into the bloodstream. So now it's a little more balanced. Okay, this is going to stay in our bodies. This is going to leave our bodies as urine. Okay, so the reabsorbing of water, how does it work? Well, guys, you probably already know this. When you drink a lot of water, what happens? Don't you pee a lot? Yeah, because when it goes to your kidneys can do the balance and say, okay, we got a lot of water, let's throw out a bunch. So you drink a lot of water, man, you're peeing every 2 to 3 hours, right? On the other hand, what happens when you don't drink enough water? How often do you pee? Probably not as much, okay? Because your body's like, wait a minute, we need water. Now, your kidneys has to, I mean, in order to urinate, you got to have some water. So your kidneys are going to release some water, water, but it's not going to release a lot. It's going to be like the bare minimum. So if you're dehydrated, one of the clear signs that you're dehydrated is one, you pee less, and two, when you pee, your urine is very concentrated. So it might be very yellow, may have a very strong smell to it. It's concentrated because you have lots of waste products and less water to dilute it out. Hence, when you urinate, it tends to appear, like I said, maybe colored, usually very yellow. It may have a very strong smell to it because it's concentrated. On the other hand, when you drink lots of water, your body can throw out a lot of water. Hence, your urine becomes more diluted. And so hence, throughout the day, you urinate, the water's clear. Lots of it. It may have very little smell or no smell at all. That means that you're drinking plenty of water. Hence, your body can dilute out that urine and it just comes out clear. And like I said, with very little smell. Okay. So like I was saying, that's your urine. So here comes your urine here. The stuff that's left over goes out your body through the ureter into your bladder. Everything else goes to what they call your renal vein, which goes back into your heart. Okay, so just to show you what I'm talking about when I say renal vein. Okay, so here's my this here, the renal vein is going to go away. So it's going to come out here. See, it says renal vein. It's the blue one here. So this is clean blood from the kidney going here to your heart. The blood coming from your heart is going to go into the kidneys to get cleaned and then come out like that. So when your kidneys doesn't clean all your blood at once, obviously, because that ain't gonna happen. So you get some blood from your heart that goes straight to your body. Some blood from your heart's gonna go into the kidneys to get cleaned. And after it gets cleaned, it comes back here and goes back up to your heart to get oxygen. All right, so just so you understand how the basic anatomy works there. Okay, so let me go ahead, almost done. All right, so then it's gonna go and sit in your bladder and then go from there. Now, video on kidney filtration, I'm gonna upload this into Canvas, please watch it. Now, you guys actually have a water consumption project that's in Canvas. You can read about that later, but it's very, very important that we have enough water. Why? Because 2/3 of our body is made of water. Guys, you're like a walking cup of water. Okay, so we're 2/3 of water. We lose too much water by sweating or urination. We will get dehydrated, excuse me. Dehydration causes your blood pressure to drop significantly and you will die. Guys, we can go days without food. You can only go maybe a few, I want to say it's 2-3 days at the most without water. I need to look that up again. But you can't go very long without water. It's just like a couple of days. I think it's maybe a day or two, something like that. Without drinking any water, you will not survive. You can go without food for weeks, depending on, your personal size. I mean, obviously a heavier person can go longer than a skinny person. But water, you will die within a few days if you do not have water. That's how important water is. We have to stay hydrated. Because if we don't have the water, because guys, you're gonna urinate, you're gonna sweat. Those things are gonna have to happen for your body to remove the waste products. You get dehydrated, you will die within a few days. Now, what happens if you don't drink enough water? Okay, kidney stone, this video is gonna be up for you guys to watch. Please watch it, but I do wanna show this to you. Kidney stones are very common among males, but girls can get them. Look here at this picture. This is a picture of a kidney stone. What is a kidney stone? A kidney stone happens when you do not drink enough water. Remember I told you if you don't drink water, the urine gets concentrated. Well, here goes back to your kidneys. If I don't have enough water, your kidney is not going to release all of that water. It's going to release a minimal amount. So hence, all of the ions, the salt, the urea, all that stuff that's in your bloodstream is coming out with very little water, and it can actually crystallize. It becomes like a crystal. That crystal is a stone in your bloodstream, in your kidney. Now, look at the size of your ureter. Look at the size of the stone. Look at the size of the ureter. Look at the size of the stone. Even the opening from your bladder into your urethra, it's a small opening. Why? Because it's for water, not a stone. So guess what happens when this, and do you see this? Do you notice that the stone is not smooth? It's not a pebble, okay? You know what I'm saying? Kidney stones are not cute little pebbles. Do you see it is a crystal? And if you've ever touched a crystal, crystals have sharp edges. Do you see the sharp edges? Can you guess what happens when this sharp-edged object tries to squeeze through your ureter? What do you think it's gonna feel like? What happens when it tries to go through your urethra to leave the body? What is it gonna feel like? Okay, I have heard they say that when a guy passes a kidney stone, the pain that they feel is equivalent to childbirth. That's how painful passing one of these crystallized sharp stones are for a guy. It's the equivalent of childbirth. Yeah. And please remember, it's two paths. So if a guy has developed a kidney stone because they refuse to drink water, they have the pain of it coming down the ureter, then it sits in your bladder. That part doesn't hurt. But that's a sense of anticipation because we all know it has a second path to get out of the body, which is a urethra. The urethra is the tube that releases it from the body. You guys all know where that is. That's where the kidney stone is going to come out. This thing came out of there. So, hence, that's why it's so important for you to drink water. You don't want this to happen to you. Like I said, girls can get it too. Boys, it seems to happen more with boys than girls, but girls can have it. This is why drinking water is so important. Your water consumption project focuses on this diagram here. Most of you guys are about 14, so this is the amount of water you should drink daily. Go to your water consumption project to learn more about that. I'm gonna go ahead and move on. So we've talked about temperature regulation, glucose level control, and water level control. These are all examples they call negative feedbacks. It's a negative feedback because it's going to go in the opposite direction. What does that mean? My temperature gets hot, my body wants to cool it down. That's negative, it's going the opposite direction. My body is too cold, the temperature goes down, my body wants to bring it up. That's in the negative, in the opposite direction. My sugar level's too high, my body wants to bring it down. That's in the opposite direction, it's negative. My blood sugar is too low, my body wants to bring it up. That's negative, it's in the opposite direction, okay? My water level is too high. I urine more to bring the water level down, negative. I don't drink enough water, I have less urine because I want the water to go up, that's a negative reaction. There are some positive feedback systems, and this is an example of positive feedback system. Childbirth, why do I say that? Because the way it works is when a woman's about to give birth, the pain is very low and dull, probably the equivalent to monthly cramps. But over time, those contractions build upon themselves so that the closer the woman gets to the actual delivery of the child, the pain increases and increases and increases. It feeds, it feeds itself. It gets more and more and more. That's a positive feedback because when the pain comes, the next one is more and it's more and it's more and it grows and it grows and it grows. That's a positive feedback system. So childbirth is an example of a positive feedback. All of the other ones that we did were negative because it's going to lower. Childbirth, everything increases. It's in the opposite direction. This, by the way, is my son, which is why I have him there because I got the joy of experiencing some positive feedback when I gave birth to him. So this is him actually last year when he was 3. He's 4 now. All right, so that is it, guys. We're going to stop this recording here. The next recording is going to be on homeostasis in plants, but this one was just focusing on us. So I hope you guys enjoyed it and think about our bodies, okay? Please make sure you watch those videos that I have for you in Canvas to help build on what we've talked about, to help you to remember the things that we've learned. All right, guys, take care, and I will see you in the next video. Bye-bye.